Okay, so now we will solve few questions related to this topic of buoyancy. The very first question says a spherical balloon of weight 2 kilonewton is tied to a wire connected to the bottom of the tank. The diameter of balloon is 2 meter. Calculate the tension in the wire. Okay, so we have got the spherical balloon which is tied. This is our water surface. Okay, and the spherical balloon is connected to the bottom of the tank. Okay, the weight of this spherical balloon is given as 2 kilonewton acting downwards. Obviously, we have to calculate the tension acting on this wire. Getting this or not? Okay, so how can we calculate this? So as I told you, the buoyancy force, buoyant force will act here. Okay, if I this buoyancy force will act upwards. Okay, so for equilibrium, this Fb will be equal to W plus T. We have to determine the tension, this T in the wire. So for that we will have to determine this buoyancy Fb, and Fb as we know is nothing but weight of the liquid displaced, as I told you. Okay, or you can write it as rho g into V, where V is the volume of solid immersed. Getting this? Okay, so this will be equal to rho g means 9810 into V volume, and volume of this sphere is, as we know, is 4 by 3 pi r cube. So just put the value. This will be 9810 into 4 by 3 pi into radius. The diameter is given as 2 meter, radius is 1 meter, 1 cube. So from here this buoyant force Fb will be equal to 41.09 kilonewton. Getting this? Okay, now we have to determine this tension. So this tension T will be equal to Fb minus W. Okay, so this will be equal to 41.09 minus W, weight is 2 kilonewton. So this will be, this tension will be equal to 39.1 kilonewton. Answer. Getting this? So this is how we can solve this question. Okay, next question. Next question says a solid body of 100 Newton is placed into water. Its weight in water is 80 Newton. Calculate relative density or specific gravity of body. Okay, so the relative density of submerged body, you can write the formula. Is equal to, if you want to calculate relative density, this relative density is equal to weight of body in air divided by whatever loss we are having in fluid, loss of weight in fluid, into specific gravity of fluid. Okay, this is how you can determine the relative density of any submerged body. You just have to check what is the weight of that particular body in air, then the loss of weight in fluid into specific gravity of the fluid. Okay, so this will be equal to, so from here this weight in air is given as 100 Newton divided by loss of weight in fluid. Okay, so weight in water is 80 Newton. So what is the loss? 100 minus 80 into specific gravity of fluid, which is 1, as we know. So from here this will be equal to 100 by 20, which is 5. Okay, now suppose in the same problem, if the fluid given is kerosene, for example, okay, so then we will have to multiply it by specific gravity of kerosene, which is 0.8. Getting this? In this case, the fluid given is water and the specific gravity of water is 1. So whatever the fluid is given, you can determine it accordingly. Getting this? Okay, now next question. A cylindrical log of diameter d, height h and gamma 0.8 floats in water with its longitudinal axis vertical. Calculate the critical height of wooden log for stability. Okay, now we have got a cylindrical log of wood whose diameter is d and height is h. Okay, it is floating in the water. So we have got, this is our water surface and this cylindrical log is floating in the water. Okay, diameter is given as d and height is given as h. Okay, the gamma of water is given as 0.8. with its longitudinal axis vertical. We have to determine the critical height of the wooden log for stability. Okay, so what is required for stability, as this is a floating body? Okay, so as I told you, for stability this GM should be greater than or equal to 0, metacentric height. And for critical, we have to determine the critical height. So for critical position, this GM should be equal to 0. Okay, and this GM, as I told you, is I by V minus BG. So this I by V minus BG should be equal to 0. Okay, so for this, we will have to determine this volume, and this volume is nothing but the volume of the solid immersed. And for that, we will have to determine this height, suppose H star. Okay, this height H star we have to determine. That means the height which is immersed inside the fluid, inside the water. So how to determine this? So for this, what we can do is, we know what total weight of the cylindrical log, total weight of cylindrical log is equal to weight of liquid displaced. Okay. Now what is the weight of the cylindrical log? This is nothing but volume into density into G. So total volume is pi by 4 into D square into H into density. Specific gravity is given as 0.8. So density is 0.8 into 1000 into 9.81. Okay, this is nothing but total weight of liquid displaced. Getting this? Okay, so this is the total weight of liquid displaced. Now this diameter is capital D, sorry. Okay, so this is total weight of liquid displaced. Now this is weight of liquid displaced, so what will be the volume of liquid displaced or volume of water displaced? So this is nothing but total weight of the liquid displaced divided by specific gravity. Okay, so this will be equal to total weight displaced is pi by 4 D square H into 0.8 into 9810 divided by 9810. Getting this or not? Okay, so this much volume of water will be displaced. Now total whatever volume of water is displaced is nothing but the volume of this cylindrical log which is immersed inside the fluid. Whatever volume of water is displaced will be equal to the volume of cylindrical log which is immersed inside the fluid. Okay, so this is the this is actually the volume of cylindrical log immersed inside the fluid. So what is the height immersed, which is H star? So this is nothing but volume immersed divided by area of cross section. Getting this or not? Okay, so from here this will be equal to, this 9810 will get cancelled out, pi by 4 D square H into 0.8 divided by area. Area is nothing but pi by 4 into D square. Okay, so this will be cancelled out and this will be finally 0.8 of H. That means this H star is equal to 0.8 of H. This much height of the liquid is immersed inside the fluid. Getting this or not? Okay, and once we get the height, we can determine the volume of this. Okay, second thing which we have to determine is BG, and for that we will have to determine the center of buoyancy. Okay, so center of buoyancy, how can we determine? So this much height is immersed, so center of buoyancy will be equal to what? As I have already told you, the center of buoyancy will be equal to 0.5 of H star. Okay, so this will be equal to 0.5 into 0.8 of H. So this will be equal to 0.4 of H. This is center of buoyancy. Getting this? Okay. Now, as I told you, for stability, this GM should be equal to 0, or you can say I by V minus BG. This should be equal to 0. Now, what is I? I is pi by 64 d raised power 4 divided by volume immersed is pi by 4 d square into height immersed pi by 4 d square into this much height. Okay, so this will be 0.8 of H minus the distance between B and G. Okay, so the center of buoyancy is at a distance of 0.4 H from bottom. This is center of buoyancy, and center of gravity, as we know, will be at a distance of 0.5 H from bottom. Getting this or not? Okay, so this is 0.4 H and this will be 0.5 of H at center. Okay, so what will be BG? So this BG will be equal to distance between center of gravity and center of buoyancy, 0.5 H minus 0.4 H, which is equal to 0.1 of H. Okay, so this will be minus 0.1 H this should be equal to 0. Okay, so from here we will get the value of this h, which will be equal to 0.89 of D. Answer. Getting this or not?